Download this code from codegive.com, link in the description below. OK, let's dive deep into server-side template injection, SSTI. This is a serious vulnerability that can allow attackers to execute arbitrary code on your web server. I'll provide a comprehensive explanation, complete with code examples, prevention strategies, and real-world considerations. What is server-side template injection, SSTI? SSTI vulnerabilities occur when a web application embeds user-controlled input directly into a template engine without proper sanitization or escaping. Template engines are designed to render dynamic content, allowing developers to separate presentation logic from the application's code. Examples include Jinjia 2, Python, Twig, PHP, freemarker, Java, and many more. Instead of just rendering a simple variable, a template engine might execute code snippets provided by the user if the application isn't careful. This becomes a huge problem if an attacker can manipulate the input used within the template. The attacker essentially gains the ability to inject and execute code on the server. Why is SSTI dangerous? Remote code execution, RCE. The most critical risk is the ability for an attacker to execute arbitrary operating system commands on the server. They can read files, write files, install malware, or even take complete control of the server. Data exfiltration. Attackers can access sensitive data stored on the server, including databases, configuration files, and user credentials. Denial of service. DOS attackers can crash the server or consume excessive resources, making the application unavailable to legitimate users. Privilege escalation. If the application runs with elevated privileges, the attacker can potentially escalate their privileges and gain even greater control over the system. How SSTI works, the mechanics. The core of SSTI lies in the interaction between user input and the template engine. Let's illustrate with examples. Example 1, Python and Jinjia 2. In this code 1, we have a Flask application with a/hello root. 2, the name parameter is retrieved from the URL query string, example name equals John. 3, the name is then directly injected into an HTML template string using format. 4, render_template_ string, renders this string. Vulnerable input *. If an attacker provides input like this, the output will be. This is because Jinjia 2 evaluates the expression 7*7 before rendering the template. This demonstrates that the template engine is executing code. The real attack *. A more malicious payload. This attempts to access Flask's configuration object, config, and display its items. The output may reveal sensitive information, such as the secret _key, which is crucial for securing the application. Going further, RCE in Jinjia 2. To achieve remote code execution, RCE, we can leverage Jinjia 2's capabilities to access Python objects and execute system commands. The exact payload can be complex and depend on the specific Jinjia 2 version and environment, but a common approach involves finding a way to access os.system or a similar function. Here's a general example, which may need adjustments for different versions. Explanation of the RCE payload, Jinjia 2 example. This payload is designed to navigate the Python object hierarchy to find a way to execute system commands. *__class__ gets the class of an empty string, which is class str. *__row___ gets the method resolution order, the inheritance hierarchy. This returns a tuple of classes. *2 accesses the third element of the tuple, usually class object. *__subclasses ___, gets a list of all subclasses of object. This is a very long list. The vulnerability lies in the fact that this list includes classes that can be used to execute code. *71, this index is extremely sensitive to the environment. The index 71 is often associated with class os_wrap_close, but this can change with Python versions. This class is important because it often provides access to the OS module. *init__globals__ accesses the global variables within the __init__ method of the class. This is where the OS module is often located. *os.system ID accesses the OS module and calls the system function to execute the ID command, which displays the user ID, group ID, and other information. Important considerations about the RCE example ***. The 71 index is highly variable. It will change depending on the Python version, installed libraries, and other factors. Finding the correct index often requires brute forcing or careful examination of the available subclasses. Automated ssti tools often use fuzzing techniques to find the correct index. This is a complex exploit. SSTI is not always straightforward. The exact payload depends heavily on the template engine, its configuration, and the available objects and functions. Example 2, PHP and twig. Vulnerable input **. Output RCE, twig. Explanation, twig RCE. *_self, refers to the current template object. *env, accesses the twig environment. *register undefined filter callback, system, registers a callback function that will be called when an undefined filter is used. In this case, we're registering the system function. *getFilter, ID, calls the ID filter, which is now mapped to the system function. Example 3, Java and freemarker. Vulnerable input *RCE, freemarker. Explanation, freemarker RCE. *freemarker.template.utility.execute, accesses the execute class, which allows executing system commands. *new, creates a new instance of the execute class. *ID, calls the execute class's method to execute the ID command. Common template engine syntax and payloads. Here's a quick reference table of common SSTI payloads for various template engines. Remember that these are starting points, and the exact payload may need adjustments. Template engine syntax RCE payload, example. --. Jinjia 2, Python. __class__dot__mro________ _2 _71 _init _globals _os.system, ID, highly version dependent. Twig, PHP. _self.env.register undefined filter callback, system, _self.env.getFilter, ID. Freemarker, Java, $freemarker.template.utility.execute, new, ID. Velocity, Java, $runtime.getRuntime.exec, ID. Thimaleaf, Java, or $t, java.lang.runtime.getRuntime.exec, ID. Smarty, PHP. PHP ecosystem, ID, /PHP, if PHP tag is enabled, which is extremely rare and dangerous. Pebble, Java. Exec, ID, if the exec function is exposed, which is generally not the default configuration. Pebble is generally considered more secure by default. Jade/Pug, Node.js, Jade/Pug are generally not vulnerable by default because they focus on HTML generation. However, if you're using custom filters or functions, vulnerabilities could be introduced. General detection strategies. 1. Fuzzing ** send various payloads to the input fields and look for signs of code execution. Start with basic arithmetic expressions like 77 or $77. 2. Error messages * look for error messages that reveal the template engine being used or internal details of the application. For example, an invalid syntax error might reveal the presence of Jinjia 2. 3. Context-aware payloads * adapt your payloads to the expected data type. If the input is supposed to be a string, try string-based operations. 4. Blind ssti * sometimes, the output of the template is not directly visible. In these cases, you can try to trigger side effects, such as writing to a file or making a network request. Tools like Burp Collaborator can be helpful for detecting these. 5. Automated tools * use tools like TableMap to automate the detection and exploitation of ssti vulnerabilities. These tools perform fuzzing and attempt to identify the template engine in use. Prevention strategies, the most important part. 1. Input sanitization and validation * never trust user input * treat all user input as potentially malicious. * whitelisting * define a strict whitelist of allowed characters and data formats. Reject any input that doesn't conform to the whitelist. This is the most secure approach. Escaping * if you can't whitelist, carefully escape user input before embedding it in the template. Use the template engine's built-in escaping functions to prevent code execution. For example, in Jinjia 2, use the e-filter or auto-escaping. * data type validation * ensure that the input matches the expected data type. If you expect an integer, reject non-numeric input. 2. Template engine configuration * sandbox mode * many template engines offer a sandbox mode or restricted execution environment that limits the capabilities of the template engine. Enable this mode to prevent attackers from accessing dangerous functions or objects. * disable dangerous features * disable any features of the template engine that are not strictly necessary. For example, if you don't need to execute arbitrary code, disable the ability to execute code snippets within the template. * update regularly * keep your template engine and its dependencies up to date to patch any known vulnerabilities. 3. Code review * manual code review * have experienced developers review your code to identify potential ssti vulnerabilities. Static analysis tools use static analysis tools to automatically scan your code for common ssti patterns. 4. Principle of least privilege run the application with the minimum necessary privileges. This limits the damage that an attacker can do if they successfully exploit an ssti vulnerability. 5. Content security policy, CSP. Use CSP to restrict the sources from which the browser can load resources. This can help to prevent attackers from injecting malicious JavaScript into the page. Important note CSP does not directly prevent SSTI. It's a defense in-depth measure that can mitigate the impact of other vulnerabilities, including XSS that might be a consequence of SSTI. 6. Consider alternative templating strategies ***. Logic-less templates ** use template engines that intentionally restrict code execution within templates. This can reduce the risk of SSTI. Pre-rendering ** if possible, pre-render the templates at build time or during deployment. This eliminates the need to dynamically render templates at runtime, which can reduce the attack surface. Code example, Secure Jinjia 2 implementation, with escaping. In this secure example, 1. We use markup safe.escape, to escape the name parameter before embedding it in the template. This prevents the template engine from interpreting potentially malicious code. This will render the brackets etc. as entities to avoid code execution. 2. Important asterisk while escaping prevents direct code execution, it might not be sufficient if the application relies on other features that could be exploited. Whitelisting is always the preferred approach. Code example, Secure Jinjia 2 with whitelisting. This is a much stronger approach. Real-world considerations. Legacy applications. Many older applications were not designed with security in mind and may be particularly vulnerable to ssti. Frameworks and libraries. Be aware of the ssti risks associated with the frameworks and libraries you use. Follow the security best practices for each technology. Third-party components. If you use third-party components, make sure to keep them up to date and review their security posture. Defense in depth. Implement multiple layers of security to protect your application. Even if one layer is compromised, the other layers can help to prevent a successful attack. Regular security audits. Conduct regular security audits of your application to identify and address potential vulnerabilities. Testing for ssti. 1. Manual testing. The best way to understand ssti is to try to exploit it yourself. Experiment with different payloads and template engines to see how they behave. 2. Automated tools. Use tools like TeepleMap and Burp Suite to automate the process of detecting and exploiting ssti vulnerabilities. 3. Penetration testing. Hire a professional penetration tester to assess the security of your application. Key takeaways. SSTI is a severe vulnerability that can lead to remote code execution. Never trust user input and always sanitize or escape it before embedding it in a template. Configure your template engine securely and disable any unnecessary features. Implement multiple layers of security to protect your application. Keep your software up to date and conduct regular security audits. Whitelisting user input is the most effective defense. I hope this comprehensive tutorial provides a clear understanding of SSTI, its dangers, and how to prevent it. Remember that security is an ongoing process, and you should always be vigilant about protecting your applications from attack. Good luck.